This problem goes with slide number 9 from the stoichiometry notes, and this is our third practice problem. For this one, it's asking how many grams of carbon dioxide is made during the combustion of 8.6 grams of C2H2 gas. The first step in any stoichiometry problem is to balance the chemical equation if it is not already balanced for you. For this one, I already know what the coefficients should be, so I'm just going to have us start with the oxygens here. On the left-hand side, there's 2 oxygens. On the right-hand side, there's 2 here, but there's also another one here. If you look at the left-hand side, we can only have even numbers of oxygens, but we have an odd number here. So to eliminate that problem, I'm just going to go ahead and start with putting a 2 here, and then that should help us out. So when I put a 2 here, that gives me 2 times 2, 4 hydrogens. I'm going to need a 2 here. So 2 times 2 is 4. When I put that 2 here, I also now have 4 carbons, so I need to put a 4 here. And now I need to count up the oxygens. I have 4 times 2 is 8, and 2 times 1, so 8 and 2 is 10. 2 times what will give you 10 oxygens? And you would need a 5 here. Now that we have the balanced chemical equation, we can go ahead and start doing the calculation. It says that I start with 8.6 grams of C2H2. Remember, in order to convert from one substance to another, you always need to get it into moles first. So that's the first thing I'm going to do. I'm going to convert this to moles. So grams C2H2 on top, that same unit has to go on the bottom. Moles on top. And 1 mole of C2H2 is equal the grams from the periodic table. So you need to add up 2 carbons and 2 hydrogens. So that would be 12 plus 12 plus 1 plus 1. That gives me a total molar mass of this of 26 grams. Cancel those. Don't cross out the number though. And then our next step is going to be to convert from moles of the C2H2 into moles of our target unit or our target substance, which is carbon dioxide. So moles of C2H2 go on bottom. Moles of our target substance, which is CO2. And then remember, in your stoichiometry problem, this is where the coefficients come into play. So the number in front of C2H2 is 2. The number in front of CO2 is 4. In this step, I can cancel moles of C2H2. And now we're left in moles of CO2. But look what it's asking. It's asking for grams. So we need one more step to convert moles of CO2 into grams. Times in a line. Moles CO2, grams CO2. In 1 mole of CO2, it should equal grams from the periodic table. So you need to add up 1 carbon and 2 oxygens. 12 plus 16 plus 16. That would be 44 grams. Moles of CO2 cancel. And now you need to multiply across the top and then divide by the bottom. So the math on this would be 8.6 times 1, don't need to do that, times 4, times 44, hit enter, and then divide by the bottom. 26 times 2 times 1, don't need to do that. And that gives me 29.1, and my units are grams of CO2.